Okay, day 2, we're going to use the first and second derivative to perform tests on functions to see where we have certain characteristics. So we look at the graphs and we saw where things were increasing and decreasing and concave up and concave down, and we could see what the graphs of f prime and f double prime will look like. Well, we're going to do the same idea of deciding what f prime and f double prime look like, but just looking at the equations of the functions, not the graphs. So again, we have f prime is positive, the function is increasing, f prime is negative, the function is decreasing, and when f double prime is positive, the function is concave up, and when f double prime is negative, the function is concave down. So the first part we're going to look at is, well, how about when things are equal to 0? When f prime is equal to 0, these are called critical points. Something critical is happening there. For right now, this is usually when there is a min or a max. Okay, there's other conditions that could happen, but we're not really going to get into those right now in calculus, maybe at a later date. The other thing is when f double prime is 0. These are called inflection points. This is the point where the function changes from concave up to concave down, or vice versa. So let's try an example. I have a function here. Well, what do I need to do? Well, basically what we've been doing for the last month. Take the derivative. So I look at this function, and I say f prime of x is equal to 6x minus 4, and to find the critical points, if I want to find critical points, I should take f prime and set it equal to 0. So I set this equal to 0. I solve for x, and I add 4, divide by 6, I get 2/3. So x equals 2/3 is a critical point. So what I'm going to do? Well, I'm going to draw that number line. That's what I did yesterday, was use these values to draw a number line. So x equals 2/3 is my critical point. It's a 0 value, but this is not a f number line. This is the number line for f prime, or the derivative. Again, my leading term for this problem is 6x, because I'm looking at the derivative, not the original function. And obviously on this side it's positive. This is not a bouncer, so this is negative. So this is where I have established where my number line is positive and negative, and then I could look at this and determine where things are increasing and decreasing. So when f prime is equal to a positive, I have an increasing function, and that is from 2/3 to infinity. And when f prime is equal to a negative, I have a decreasing function, and that is from negative infinity to 2/3. And if you look at the original function, you should recognize this original function as some concave up parabola that the first half has a negative slope, its vertex is a minimum and has 0 slope, and the right side of it has a positive slope. And that's kind of what I've established here. Okay, here we go again. We're going to take a function. We're going to take its derivative, 3x squared minus 8x, and to find a critical point, I set this equal to 0. I can factor out an x, and I get 3x minus 8 is equal to 0, and I get 2 values for x as my critical points. The g prime had a x squared in it. I should have 2 critical points. So I'm going to draw a number line. Remember, this number line represents the derivative, g prime. I have 0 and 8/3 on this number line. Those are the critical points. My leading term is equal to 3x squared, which tells me it goes positive on the right, negative because there's no bouncers, and positive on the left. And therefore, where are things increasing and decreasing? Well, my increasing part is negative infinity to 0, union 8/3 to infinity. My decreasing part is where it's negative, 0 to 8/3. And now I'm going to do the second derivative to find the inflection point. So I take the second derivative. So I have g double prime of x is equal to 6x minus 8. And again, I'm going to set that equal to 0. And I set this equal to 0. Got x equals plus 8 over 6, or 4/3. So these are my critical points. And this is in my inflection point. So again, I'm going to create a number line. Except this number line is a g double prime number line. The only number I have on this number line is 4/3. My leading term of g double prime is 6x, which means the right side goes positive, left side goes negative. So I have things are concave up from 4/3 to infinity. Things are concave down from negative infinity to 4/3. So I figured out critical points, increasing, decreasing, inflection point, concave up and concave down. But the other thing I can figure out, which ones are mins and which ones are maxes. So that's what this is talking about here. I could tell that an x value is going to be a min or a max depending on how the slopes are going. So if I have a slope that goes positive to 0 to negative, that means it's increasing to decreasing, that's going to give me a maximum. Because it goes positive, 0, negative slope. So right here is a max. Positive, 0, negative slopes. And conversely, if I have a slope that goes negative, 0 to positive, I have a min, because it looks like this, that I have a negative slope, a 0 slope, a positive slope, and this is a minimum. So if I go back to part B, I had, this was my G prime number line. 0 and 8/3 were on here. Those were my critical points, and I want positive, negative, positive. So if I look at this, positive, negative, positive, right here at 0, positive, 0, negative, I said this is a maximum. So at x equals 0, it is a max, since g prime goes positive, 0, negative. And 8/3 is a min, since g prime goes negative, 0, positive. Basically, positive, 0, negative means something goes uphill, 0, and downhill. That is a concave down graph. That means I have a maximum. Okay. Write that down. This all implies that this part has to be concave down, and this implies that it has to be concave up. So if I really wanted to draw what this graph looks like, taking all this information, I have a graph that goes increasing, decreasing, increasing. Now I'm not going to put any x or y axis on here, but I know right here at this max, this is x equals 0. Right here at this min, this is x equals 8/3. And right here, the inflection point is x equals 4/3. This is what the graph looks like, and I gave you the x values that key features are happening at. Okay, let's try another example from the beginning. So the first thing I want to do is take h prime, 6x squared minus 18x minus 168. I'm going to set it equal to 0. And I want to factor it, and I say, you know what? I see I could take a 6 out. I'd rather work with smaller numbers. And when I factor this, I got to be careful here. I know I have a 6 up front, but there's no variable with it, so there's not going to be a solution for that. But I do have x equals -4 and x equals 7 as my critical points. They could be mins or maxes. And there only should be 2 because this was an x squared problem. So I'll make my number line. This is an h prime number line. This is the derivative. -4 and 7 are my critical points. My leading term for the derivative of 6x squared, which means it goes positive, negative, positive. That means this graph is increasing from -infinity to -4 in union with 7 to infinity. And it is decreasing from -4 to 7. Now, how can I tell if something is a min or a max? Let me move this up just slightly a little bit. Well, I have to look at the trend for the slopes. So when I look at this, it goes positive, 0, negative. This is a max. So I have a max at x equals -4 because my derivative goes positive, 0, negative. And this is a min at x equals 7 because my derivative goes -0, positive. Now I have to figure out the inflection point. So what I have to do, and I'm going to just do it for a second here, I need to take the second derivative. So h double prime of x is going to equal to 12x minus 18. Don't take it of the red. Take it of the blue. That is the original equation of the derivative. I'm going to set it equal to 0. And I add 18 divided by 12, and I get 3/2. So I'm going to make a number line. This is an h double prime number line. Here's 3/2. That's an inflection point. The leading term of the second derivative is 12x, which means the right side is positive, left side is negative. So I have concave up from 3/2 to infinity, and concave down from -infinity to 3/2. So for this next function, it's a little bit more complicated than the other ones. To take the derivative of that function, I either have to do product rule or expand the whole thing out by multiplying it. That's what I'm going to do. I'm going to expand it. Product rule is going to give me a derivative maybe quicker, but it's not going to help me when I have to determine its critical points. So I have x times x minus 3 squared. I'll do the x minus 3 squared first, which is x times x squared minus 6x plus 9. So I get my function is x cubed minus 6x squared plus 9x. That is my function. So now I could take its derivative, because that's what I really want to do. F prime of x is equal to 3x squared minus 12x plus 9. I set that equal to 0. I see I have a 3 in common. X squared minus 4x plus 3 is equal to 0. I can factor it even more. X minus 1, x minus 3. So I get x is equal to 1 and 3. Those are my critical points. But now I've got to make a number line. We'll do it in black. Here's my number line. 1 and 3 are my key points. My leading term for the derivative is 3x squared, positive, negative, positive. So I have a increasing part, negative infinity to 1, union 3 to infinity, and a decreasing part from 1 to 3. Now how can I tell which one is a min, which one is a max? Well, positive 0, negative, this is a max, and negative 0, positive, this is a min. So I have a max at x equals 1 because my derivative, my f prime goes positive 0, negative, and I have a minimum at x equals 3 because f prime goes negative 0, positive. So where's it concave up and concave down? And the inflection point, well, that's just taking the second derivative. So I'm going to take this derivative and I'm going to do f double prime. 6x minus 12 set equals 0. Add 12 divided by 6, x equals 2. I can make a nice little number line. Here's 2. Leading term was 6x. Positive, negative. So I have concave up from 2 to infinity and concave down from negative infinity to 2. These are my critical points, and this was my inflection points. Now this next one, I don't have a choice. I have to do product rule. Oops, let me grab this. I have to do product rule. No choice. Oops, getting too close to the top. So let's see. 2x cubed turns into 6x squared. E to the x turns into e to the x. Do my crisscross. F prime of x is equal to 6x squared e to the x plus 2x cubed e to the x. I'm going to set it equals 0. I'm going to factor it. What do they have in common? Well, let's see. I see there's a 2, there's an x squared, and there's an e to the x. They all have in common. I take that out. I have a 3 plus x left over, and I have to set everything equal to 0. I set this one equal to 0. I get x equals 0. This is always positive. It never equals 0. We talked about that earlier. And this one is x equals negative 3. So when I draw a number line, I get 0 and negative 3 as my critical points. My leading term, I can ignore e to the x because it's just a positive value. My leading term is really 2x cubed because that's a higher exponent. That means I get positive, negative, positive. That means it is increasing from negative infinity to 0. Union. Wow, it'd be nice if I did this number line correctly. I'm losing my mind. Get the cheater a little bit. Negative 3 to 0. Put my numbers in order. I also have to pay attention. Sorry about that. This is wrong. Really need to pay attention. Let me erase that. There's a squared here. This is a bouncer. 0 is a bouncer. My leading term is 2x to the third. That means this side is positive. Bounce positive, goes negative. This is how I double check. A bouncer makes it positive on both sides. X to the third means that ends have to be opposite. So if I want to do this correctly, it is increasing from -3 to 0, union 0 to infinity, and it is decreasing from -infinity to -3. Yes, I need to pay better attention and not just go through the motions. And there we go. Now, I have to do mins and maxes. Well, I'm going to redraw the number line. It's kind of crowded over there. Negative, positive, positive. And what makes it a min or a max? Well, -0 positive means it is a min. So at x equals -3, this is a minimum because this is a f prime number line. F prime goes -0 positive, but at x equals 0, it's not a max or a minimum because it goes +0 positive. It is really neither. So there is no maximum. Because for a maximum, I need f prime to go +0 negative, and it never does that. But I can't do concavity. So I'm going to take my function over here. So this is my derivative function right here. And I'm going to take its second derivative. I'm going to move it up. And I'm going to figure this out. Well, I have two terms here, and they both kind of have a product rule. So I have 6x squared, 12x, e to the x, e to the x. So the first part of that double prime is going to be 12x e to the x plus 6x squared e to the x. And the second part of it is 2x cubed, 6x squared e to the x, e to the x, plus 6x squared e to the x, plus 2x cubed e to the x. And when I do this all nice together, I get f double prime of x is equal to 12x e to the x plus 12x squared e to the x plus 2x cubed e to the x. And I'm going to write it in order. F double prime of x is equal to, I can take an e to the x out of here, 2x cubed plus 12x squared plus 12x. And then I can factor even more. I can see that they have a 2 and an x. So e to the x times 2x, I get x squared plus 6x plus 6. Set that equal to 0. And this is where I get problems. Does not factor. Doesn't. Won't work out. So I got to use the quadratic formula. And I get x equals, and I do it really quickly, and I get -6 plus or minus the square root of 24 all over 2. My two x's are going to be negative 1.27, and negative 4.27. And when I create a number line for all this, negative 4.27, negative 1.27, these are my zeros. My leading term was this, really just this positive 2x cubed. There's no bouncers on this. Oh wait, there's another 0. There's a 0 here too. So I have also x equals 0, which is right here. Positive, negative, positive, negative. And it will be concave up from negative 4.27 to negative 1.27 in union with 0 to infinity. And it is concave down from negative infinity to negative 4.27 in union with negative 1.27 comma 0. It's a little bit more work. I don't know how if you're going to do these on quizzes or whatever, but I think you have to learn how to look at things other than just factoring polynomials and how e to the x may or may not have an effect on an equation or a graph. Okay. Ask questions. Do the daily assessment.